Yes, we'll discuss Fourier series. We'll start with type 1. In type 1, we have to find Fourier series of a function f of x, which is defined in the interval 0 less than equal to x less than equal to 2 pi, or in the interval 0 to 2 pi. So the question will be to find Fourier series or Fourier expansion of a function which is defined in the interval 0 to 2 pi. Now the formula for Fourier series or Fourier expansion is given by f of x is equal to a0 divided by 2 plus summation n is 1 to infinity an into cos nx plus bn into sine of nx, where a0 can be found using the formula 1 upon pi into integration with limit 0 to 2 pi f of x dx. An can be found out using the formula 1 upon pi 0 to 2 pi f of x into cos nx dx. Bn by the formula 1 upon pi integration with limit 0 to 2 pi f of x into sin nx dx. Note that when the function is defined in the interval 0 to 2 pi, limits of the integration are taken as 0 to 2 pi. The multiplier outside the integration is 1 upon pi. And in a0 we integrate f of x with respect to x. In an, so it is f of x into cos nx dx. In bn, it is f of x into sin nx dx. Also remember, whenever it is asked to find Fourier series or Fourier expansion of a function which is defined in the interval 0 to 2 pi, then we do not have to check whether the function is even or odd. We directly find a0, an, bn applying the respective formula. So in general, whenever the interval is starting from 0, we do not check whether the function is even or odd. Later on, we are going to study types where the interval will be from minus pi to plus pi, or arbitrary interval like minus l to plus l. In such case, we check whether a function is even or odd, and accordingly we get different cases whether the function is even or odd or neither even nor odd. Accordingly, we'll get 3 cases and 3 different formulas in those cases. But now here we don't have to check whether the function is even or odd. Now how to apply this in a problem itself, we'll see. Now, you see the question is find Fourier series for the function pi minus x upon 2 the whole square in the interval 0 less than x less than 2 pi. We can see that the interval is 0 to 2 pi. The question is find Fourier series, and it is given that f of x is f of x plus 2 pi. See here, this given condition f of x is equal to f of x plus 2 pi just means that the function is a periodic function. The function is periodic function with period equal to 2 pi. So the function is going to repeat its value after an interval of 2 pi. The important thing that we have to see in this question is what is asked. It is asked to find Fourier series. Later on, you will find in some other types, it is asked to find Fourier half range Fourier sine series or half range Fourier cosine series. So we should first check what is asked. Here it is asked to find Fourier series, and the interval is 0 to 2 pi. You will find we are going to study in different types, different intervals like 0 to 2 pi, minus pi to plus pi, then 0 to 2l, minus l to plus l. Here the interval is 0 to 2 pi. Now for this interval 0 to 2 pi, to find Fourier series, we know that we'll have to find a0, an, bn. First let us find a0. So the formula to find a0 is 1 upon pi into integration with limit 0 to 2 pi f of x dx. Again see, when we are finding Fourier series for a function in the interval 0 to 2 pi, we do not check whether the function is even or odd. Directly we apply this formula of a0, and now we know f of x here is pi minus x upon 2 the whole square. Now we can simplify this. So we can write this as square of pi minus x divided by square of 2. Square of 2 will be 4. This 4 we can take it outside. It will be 4 pi. And we have to now integrate pi minus x the whole square with respect to x. Now see, this term we can integrate in different ways. One is you directly apply this formula. Integration of ax plus b raised to n dx is equal to ax plus b raised to n plus 1 upon n plus 1 into 1 upon a, where that a is the coefficient of x. We can apply this formula. Now I have applied the same formula, or you may expand this bracket using a minus b the whole square and then integrate. Whatever you find easy. Like I use this formula. So if you compare this formula here, in place of n it is 2, in place of ax plus b it is pi minus x. A, remember, is the coefficient of x. A is minus 1, b is pi here, and n is 2. So if you integrate this pi minus x the whole square using this formula, it becomes pi minus x raised to 2 plus 1 upon 2 plus 1. So see, the formula is integration ax plus b raised to n dx is ax plus b raised to n plus 1 upon n plus 1 into 1 upon a. Here in place of n it is 2, This becomes pi minus x raised to 2 plus 1 upon 2 plus 1. So it becomes pi minus x the whole cube upon 3. And remember, it is also into 1 upon a, where a is the coefficient of x. The coefficient of x is minus 1. So into that 1 upon a becomes into 1 upon minus 1. So this minus 1 into 3 becomes minus 3. And now this is within the limit 0 to 2 pi. Remember, here 0 is the lower limit, 2 pi is the upper limit. Now we'll put the limits, and when you put the limits, remember, always we put the upper limit first in place of x. First we'll put the upper limit 2 pi in place of x minus, then we'll put the lower limit in place of x. Remember, it is always upper limit minus the lower limits. And also we can take this minus 3 outside. Minus 3 into 4 is going to be minus 12 into that pi. So it will be minus 12 pi. Now, yes, so to find a0 now, I'll take this minus 3 outside. Minus 3 into 4 pi will become minus 12 pi. Now, if I put the upper limit 2 pi in place of x, if you put upper limit 2 pi in place of x, it becomes pi minus 2 pi the whole cube. It is upper limit 2 pi I am substituting in place of x, so it is pi minus 2 pi the whole cube minus the lower limit in place of x. If I write 0, it is pi minus 0 the whole cube. Minus 3 we have taken already outside. Pi minus 2 pi becomes minus pi. Cube of minus pi is minus pi cube. This becomes pi cube. So see, it was upper limit minus lower limit. Minus pi cube becomes minus 2 pi cube. Minus into minus becomes plus. Pi cube upon pi becomes pi square. 2 upon 12 becomes 6. That 1 by 6. So we get a0 is pi square upon 6. We have found out the value of a0. Now we have to find an. See, the formula to find an is 1 upon pi integration with limit 0 to 2 pi f of x into cos of nx dx. Right? So this is the formula we know, which we have to apply, which we can apply when the limits are from 0 to 2 pi. Okay. Now, if we substitute the value of f of x, the f of x is pi minus x the whole square upon 2 square, that is 4 into cos of nx dx. Just substitute the value of f of x, the given value of f of x. We can take this 4 outside, so it will be 1 upon 4 pi integration with limit 0 to 2 pi pi minus x the whole square into cos of nx dx. And now, see, to integrate this, we can apply the shortcut formula of integration by parts. That is integration u v dx. Integration of u into v dx is u into v1 minus u dash into v2 plus u double dash into v3 minus u triple dash into v4 plus dot dot dot. We know that this is a never ending formula, you can say. And here it is alternate plus minus plus minus. Dash represents derivative. Dash represents derivative. So u dash is the derivative of u double dash is the derivative of u dash, u triple dash is the derivative of u double dash, and so on. Then suffix represents the integration. Suffix represents integration. V1 is the integration of V, V2 is the integration of V1, V3 is the integration of V2, and so on. So it is alternate plus minus sign in this formula, and suffix is representing integration. V1 is integration of V, V2 is the integration of V1, and so on. So we are going to apply this formula for this term here. So let me again write that term. So an, remember, now it is 1 upon 4 pi into integration with limit 0 to 2 pi, it is pi minus x the whole square into cos of nx dx. Now, see, in our case, u is pi minus x the whole square. See, to choose that u, we use that rule of I late or light. So here, that pi minus x the whole square, this term is algebraic function. Cos nx is trigonometric function. So according to the order of light or I late, algebraic term comes before trigonometric function. So therefore we take our u as pi minus x the whole square. This is our u, and therefore u dash is the derivative of u, is derivative of pi minus x the whole square. And you see u dash, therefore the derivative of this pi minus x the whole square we know is 2 into pi minus x into derivative of pi minus x, which is minus 1. So you'll find it comes out as minus 2 into pi minus x is u dash. U double dash is the derivative of u dash. If you differentiate this term again with respect to x, we get this as, we'll get the value of u dash. Remember, in exam you may skip some steps, but I'm showing this in details so that you'll understand it well. So see, we can take that minus 2 outside, and derivative of pi minus x with respect to x will be minus 1. So it becomes 2 is our u double dash, and therefore u triple dash is the derivative of 2, that will be 0. So see, u dash is the derivative of u double dash is the derivative of u dash, and u triple dash is the derivative of u double dash. U triple dash is 0. So we'll need terms only till v2. So again, remember now here v is cos nx, v is cos of nx. Remember, integration of cos ax dx is sine of ax upon a, and similarly integration of sine ax dx we know it is minus cos ax upon a. v1 will be integration of cos nx dx. You see, integration of cos nx is sine of nx upon n. v2 is integration of sine nx upon n dx. See, this 1 upon n comes outside, and integration of sine nx, remember it will be minus cos nx upon n. So see, v is cos nx, v1 is integration of cos nx, which is sine nx upon n using this formula, and then v2 is the integration of v1, so it is integration of sine nx upon n. We'll take 1 upon n outside, this is going to be minus cos nx upon n. So we get v2 is equal to minus cos nx upon n square. So see, remember here we have terms till u double dash, u triple dash is 0. We don't have to find v4, but yes, we'll have to find v3. So see, the formula is u into v1 minus u dash v2 plus u double dash v3. We are having u double dash as 2, u triple dash is 0. So we'll have to find terms till v2. Yes, so I got v2 here. Now I'll find v3. v3 is nothing but the integration of v2. So it is integration of minus cos nx upon n square dx. We can take that minus 1 upon n square outside. It is integration of cos nx dx. Integration of cos nx sin nx upon n. It becomes minus sin nx upon n cube as our v3. This is our v3. Now, so see, we have found out v1, v2, v3. Now, see, our aim is to integrate this term 1 upon 4 pi into integration of pi minus x the whole square cos nx, for which we are going to apply the formula of integration u into v, the shortcut formula of integration by parts. I have just shown these steps in details, how to find u dash, u double dash, etc. Now here u triple dash is 0, so that last term of u triple dash into v4 is going to be 0. So we need terms only till u double dash into v3. So remember, our u is pi minus x the whole square, v is cos nx. And now we'll substitute all these values here. See, our an now becomes 1 upon 4 pi as it is. See, first it is u, that is pi minus x the whole square, u into v1. V was cos nx, v1 is sin nx upon n. So it is u into v1 term minus u dash. So that we have got it as minus 2 into pi minus x is u dash. into V2. V2 is minus cos of nx, minus cos nx upon n square, plus the derivative of this minus 2 into pi minus x is 2. So we had found out that this minus 2 is constant, then pi minus x derivative was minus 1. Minus 1 into minus 2 was 2. So that is the value of u double dash into V3. V3 is minus sine nx upon n cube. And this entire term is within the limit 0 to 2 pi. Remember, here it is u into V1 minus u dash into V2 plus u double dash into V3. Before substituting the limits, we'll just simplify this a bit. So this first term I'll write as it is, pi minus x whole square into sine of nx divided by n. Minus into minus will be plus, plus into minus will be minus, so minus 2 into pi minus x into cos of nx upon n square, plus into minus is minus 2 sine nx upon n cube in the limit 0 to 2 pi. So see, we have applied the formula by parts, integration u into v. And now we'll put the limits in place of x. Wherever there is x, we'll put the limits. Remember, it is always the upper limit minus lower limit. First of all, wherever there is x, we'll put the upper limit 2 pi. So that, see, this becomes 1 upon 4 pi. See, after practice, you may skip some steps, but now I'm writing all the steps in details so that we'll understand it well. So see, this will become pi minus 2 pi. Pi minus 2 pi will become minus pi. It is square of that. And here if I put x is pi, this will be sine of n into 2 pi. So it will become sine of n into 2 pi, or you can write sine 2n pi directly upon this n as it is. Minus this 2 into this pi minus 2 pi will be minus pi into cos of n into 2 pi will be cos of 2n pi again. We are substituting the upper limit 2 pi in place of x upon this n square as it is, minus this 2 as it is, sine of 2n pi upon n cube. See, we get this when we put the upper limit 2 pi in place of x. Wherever there was x, then we put upper limit x. Now if I put 0 in place of x, this pi minus 0 will be pi. Pi minus 0 is pi, and it is square of that, so pi square. If I put x is 0, this will be sine of 0 upon n. See, this we could have written 0 directly. We know sine 0 is 0. This minus 2 into pi. Pi minus 0 becomes pi, and here it will be cos 0 upon n square. Then minus 2 sine 0 upon n cube. This is when we put the the lower limit 0. So first bracket here, this first bracket we have got by substituting the upper limit, whereas the second bracket we have got by substituting the lower limit 0 in place of x. Now remember, in general, remember that sine of 2n pi is 0 for any integer value of n. Sine pi, 2 pi, 3 pi, 4 pi, all of them are 0. Sine 2n pi, sine 2 pi, sine 4 pi, sine 6 pi, all of them are 0. So you can remember this as a standard formula. Sine 2n pi is 0, whereas cos 2n pi is 1. Cos 2 pi, cos 4 pi, cos 6 pi, all of them are 0. And we know that sine 0 is 0, cos 0 is 1. So see, in this problem, you will find all these sine terms. Sine 2n pi will be 0, sine 0 will be 0. Cos 2n pi is 1, cos 0 is 1. So that cos terms will remain. Remaining terms are going to become 0. This multiplier 1 upon 4 pi outside the bracket as it is. First term here it will be 0. Minus into minus is plus. It is 2 pi, and cos 2n pi is 1 upon n square as it is, minus 0. Minus 0 here. If I open the bracket, minus into this 0 will be 0. Minus into minus will be plus 2 pi upon n square. Cos 0 is 1. Minus into minus is plus. Sin 0 is 0. 2 pi upon n square plus 2 pi upon n square is 4 pi upon n square. 4 pi gets cancelled and we get an is 1 upon n square. You see, following that we see that sine 2n pi terms will become 0, sine 0 becomes 0, only cos terms remain. So it is this 2 pi upon n square plus 2 pi upon n square. So it becomes 4 pi upon n square. That 4 pi gets cancelled. We get an is 1 upon n square. So see, we have found out a0, which was pi square by 6. We got an as 1 upon n square. Now we have to find bn. Let us find bn. Yes. So now we have to find bn. To find bn, the formula is 1 upon pi integration with limit 0 to 2 pi f of x into sine nx dx. Now, in our example, the value of f of x is pi minus x upon 2 the whole square. So it becomes pi minus x the whole square upon 2 square. That 2 square will be 4. I have taken it outside the integration. Now this integration is in the form integration u into v. So we can apply this formula by parts. The shortcut formula by parts, integration u dx is u into v1 minus u dash into v2 plus u double dash into v3 minus u triple dash into v4. When can we apply this formula? We can apply this formula only when u is algebraic. That means u is some term like x, x square, 1 plus x, 1 minus x. Or in simple words, we can say that we can apply this formula when u is some term, if which you go on differentiating, it becomes 0. Like, remember, for example, in this case, u is pi minus x the whole square. Derivative of pi minus x the whole square, u dash, will be 2 into pi minus x into derivative of pi minus x, which is minus 1. It becomes minus 2 into pi minus x. That is our u dash. U double dash, that is the derivative of u dash. So this minus 2 is constant, we can take it outside. Derivative of pi minus x will be minus 1. Minus 2 into minus 1 will be plus 2. And u triple dash, derivative of 2 will be 0. So see, if u is algebraic and if you go on differentiating, it becomes 0 after few iterations. So this shortcut formula can be used only when given function is algebraic, because the algebraic function, if you go on differentiating after a few derivatives, it will become 0. Like if highest power of x is 1, you will find that u double dash will be 0. If highest power of x is 2, u triple dash will be 0. So like in this case, u triple dash is 0, because in this highest power of u is going to be 2. The highest power of x in u is going to be 2. And remember, to choose what should be u, we have this order, Lie or ilet. Now a stands for algebraic function. This pi minus x the whole square is an algebraic function. Sin nx is a trigonometric function. Whichever function comes first in this order should be considered as our u. So we have taken u as pi minus x the whole square. And if you differentiate that, we get u dash as minus 2 into pi minus x, u double dash as 2, and u triple dash is 0. So since we have terms till u double dash, u triple dash is 0. So there is no need of finding v4. We'll have to find v1, v2, v3. So v1 is the integration of v. Here v is sin nx. So v1 will be integration of sin nx, that is minus cos nx upon n. v2 is the integration of v1. So when you integrate this term, that minus 1 upon n being constant, we can take outside. Integration of cos nx will be sin nx upon n, that n into n will become n square. That is our v2. And to get v3, we'll have to integrate this v2. So this minus 1 upon n square we take outside. Integration of sin nx is minus cos nx upon n, that minus into minus becomes plus, n square into n becomes n cube. So this is our v3. Now we'll apply this formula, integration u dx, to find our bn. Remember that 1 upon pi is going to remain outside. U is pi minus x the whole square and v is sin nx. So our bn now becomes, see that 1 upon 4 pi we have kept outside, the integration as it is. U was pi minus x the whole square, v was sin nx. So v1, it is u into v1, is minus cos nx upon n. So this is the term u into v1 minus u dash. We have found out that derivative of this u was minus 2 into pi minus x, that is u dash into v2. v2 integration of this v1 was minus sin nx upon n square, plus u double dash, we have found out 2, and u double dash is 2, and v3, see this was our v1, then v2, v3 is the integration of this term which we had found out as plus cos nx upon n cube. U triple dash is going to be 0, and this is within the limit 0 to 2 pi. Is within the limit 0 to 2 pi. The upper limit is 2 pi, lower limit is 0. Before we put the limits, we can just simplify this bit. So we can put the limits directly also, but I show you the simplification part. First of all, this plus into minus will be minus pi minus x. Let us simplify before substituting. So it becomes easier. This minus into plus will be minus. So this minus into minus is plus. Plus into minus is minus. So it is minus 2 into pi minus x into sine of nx upon n square. And this is plus 2 cos nx upon n cube. And this is within the limit 0 to 2 pi. Now see, if we put the limit as 2 pi, the upper limit as 2 pi in place of x. See, this will be pi minus 2 pi. Pi minus 2 pi is minus pi. Square of that will be pi square. And this minus n I have kept as it is. Here this term will be cos of 2n pi. In place of x I am writing 2 pi. 2 pi into n becomes 2n pi. So it is cos of 2n pi upon this n as it is. Minus 2 into pi minus 2 pi will be minus pi. And if I put x as 2 pi here, it will be sine of 2n pi upon this n square as it is, plus 2 cos of 2n pi upon n cube. So see what I have done, I have substituted in place of x 2 pi, the upper limit. So by substituting the upper limit, we have got this first term, first bracket, minus the lower limit. Now wherever there is x, we will put the lower limit 0. See here, it is going to be this minus and outside as it is, and this will be pi minus 0 will be pi, square of that will be pi square into cos of 0 upon n minus 2 into pi minus 0 is pi into this will be sine of 0. See, n into 0 becomes 0, so sine 0 upon n square plus 2 cos 0 upon n cube as our lower limit. This is upper limit minus lower limit. First I substitute 2 pi wherever there was x. I got this first bracket, then minus the lower limit. So wherever there is x, we substituted pi. And remember, cos 2n pi. Cos 2n pi is 1. Sine 2n pi is 0. Cos 0 is 1. And sine 0 is 0. So we substitute the respective values and then simplify. So see, we'll get bn is equal to 1 upon 4 pi into, see, this cos 2n pi is 1, so this will be minus pi square upon n. Sin 2n pi term is 0, this minus into minus is plus, but sin 2n pi is 0, so 0 into anything is going to be 0, so this entire term becomes 0. Cos 2n pi becomes 1, so this becomes 2 upon n cube. Minus into minus will be plus pi square, cos 0 is 1 upon n. Substituting cos 0 is 1, sin 0 is 0. So 0 into that 2 pi becomes 0. Last term is again 2 cos 0. So cos 0 is 1 upon this n cube as it is. Upper limit minus the lower limit. We have substituted. And yes, so again I should take care of this plus minus sign. This was minus, so this plus will become minus. So we can see that this plus 2 upon n cube minus 2 upon n cube gets cancelled. Also minus pi square by n plus pi square by n gets cancelled. So all this term inside the bracket get cancelled. Isn't it? This minus pi square by n gets cancelled with this term plus pi square by n. Also this plus 2 upon n cube will get cancelled with minus 2 upon n cube. So all these terms are going to get cancelled. And finally, therefore, we get Bn is equal to 0. So see, we found out A0, An, Bn applying the respective formula. And now we'll substitute that in the standard Fourier series formula, which we know that the Fourier series. So Fourier series for a function f of x in the interval 0 comma 2 pi is given by f of x is equal to a0 upon 2 plus summation n is 1 to infinity a n cos of nx plus bn sine of nx is 0 by 2 into a n cos x plus bn sine nx. And now we'll substitute the respective values. Remember, we have got a0 as pi square by 6, n we have got as 2 upon, sorry, 1 upon n square, sorry, n is 1 upon n square and bn is 0. We substitute the respective values. So we get f of x. Now f of x here in this case is pi minus x upon 2 the whole square. This a0 can be written a0 upon 2 can be written as 1 upon 2 into a0. It is a0 by 2 is like 1 upon 2 into a0. a0 we have got pi square upon 6. So we are substituting the respective values of a0, a and bn plus this summation n is 1 to infinity as it is. A n we have got it as 1 upon n square. This will be cos nx into 1 upon n square. That becomes cos nx upon n square. Sin nx into bn. Bn is 0. So 0 into sin nx will become 0. So we get this as pi square upon 12 plus summation n is 1 to infinity cos nx upon n square as our required Fourier series is the required Fourier series or required Fourier expansion. So see here the given function f of x was pi minus x upon 2 the whole square and the interval was 0 to 2 pi. The question was to find Fourier series. We found out a0, an, bn and then substituted in this formula the respective values and we got the required Fourier series. Thank you.